Above us, beyond clouds, beyond the sky, lies a vast ocean of stars. Each night, the Milky Way stretches across the darkness like a glowing river of light. It feels eternal, calm, and untouched. But what if this peaceful galaxy is already on a path toward a cosmic collision that will reshape everything we know? Right now, the Milky Way is moving through space. It is not still. It travels along with its stars, planets, gas clouds, and dark matter. And it is heading toward a neighboring giant, the Andromeda Galaxy. Andromeda is the closest large galaxy to ours. It contains hundreds of billions of stars, just like the Milky Way, and it is moving directly toward us. At this very moment, Andromeda is speeding closer at hundreds of kilometers every second. We cannot feel this motion. We cannot see the galaxies collide yet. But in about 4 billion years, the two galaxies will meet. Their shapes will tear apart, their stars will scatter, and new worlds will form in the aftermath. This is not a story of sudden destruction. Galaxies are mostly empty space. Stars will not crash into each other like cars on a highway. Instead, gravity will twist them into new shapes. Some stars will be thrown out into the darkness between galaxies. Others will fall toward the center, where two giant black holes, one in the Milky Way and one in Andromeda, will spiral together and merge into an even more massive black hole. But this story is not only about the future. It is about what this collision means for our sun, for Earth, for life, and for the universe itself. It is a story of creation, destruction, and transformation on a scale beyond imagination. In this journey, we will explore how galaxies move through space, why the Milky Way and Andromeda are destined to collide, and what the night sky will look like when this happens. We will travel billions of years into the future to witness the birth of a new galaxy, a cosmic giant born from the wreckage of two. This is the story of the ultimate fate of the Milky Way. The Milky Way is our home in the universe. It is not just a band of light in the sky. It is a vast galaxy made of stars, planets, gas, dust, and a mysterious substance called dark matter. It stretches for 100,000 light-years across and contains more than 100 billion stars. Our sun is one of those stars located far from the center, in one of the spiral arms of the galaxy. The Milky Way is shaped like a giant spinning disk. At its center lies a dense bulge filled with stars and a supermassive black hole. This black hole has a mass equal to millions of suns, and it silently pulls stars into orbit around it. Spiraling out from the center are long, curved arms of stars, glowing gas clouds, and newborn suns surrounded by planets. Even though it feels like Earth is standing still, everything inside the Milky Way is moving. Earth orbits the sun. The sun orbits the center of the galaxy. The entire Milky Way drifts through space inside a larger structure called the local group, a small cluster of galaxies held together by gravity. The Milky Way does not float peacefully. It interacts with its surroundings. It pulls smaller galaxies toward itself and absorbs them. Evidence of these past collisions can still be seen as streams of stars stretched across the sky. Our galaxy is a traveler, rushing through the universe at great speed. Far beyond, another galaxy is also moving through space. This is the Andromeda Galaxy. It is similar to the Milky Way in size, shape, and number of stars. For a long time, people believed it was just a fuzzy cloud in the night sky. Now we know it is a galaxy as vast as our own, and it is coming closer to us every moment. The space between the Milky Way and Andromeda is not empty. It contains dark matter, gas, and small galaxies. Gravity connects them like threads of an invisible web, and this gravity is pulling the two great galaxies toward each other. They are on a collision course. They cannot escape. The Milky Way and Andromeda are falling together, slowly but surely, drawn by the force of their combined mass. This journey will take billions of years, but the outcome is already written in the motion of the stars. The Andromeda Galaxy is the closest spiral galaxy to the Milky Way. It lies about 2.5 million light-years away from Earth. When we look at it with the naked eye, It appears as a faint blur in the night sky. But when seen through powerful telescopes, it reveals a breathtaking spiral of stars stretching more than 200,000 light-years across. Andromeda is larger than the Milky Way. It contains nearly 1 trillion stars, far more than our galaxy. Like the Milky Way, it has a bright core, spiral arms, and a supermassive black hole at its center. Around it orbit dozens of smaller dwarf galaxies, just as the Milky Way has its own companions. For a long time, astronomers believed Andromeda was stationary in the sky. But with precise instruments, they discovered something remarkable. Andromeda is moving toward us at a speed of more than 100 kilometers per second. This is not a slow drift. It is a fast, powerful movement caused by gravity. Gravity is the invisible force that shapes the universe. It is the reason planets orbit stars and stars gather into galaxies. It is also the reason galaxies pull on each other across millions of light-years. The Milky Way and Andromeda are both massive. Their gravity pulls them closer every moment. They are not just passing by. Their paths are locked. They will meet. In about 4 billion years, the two galaxies will begin to collide. This collision is not a sudden crash. It is a slow, breathtaking dance that unfolds over billions of years. The galaxies will stretch, twist, and tear as their stars are pulled by powerful gravitational tides. It may sound like a disaster, but space is mostly empty. Stars are far apart from one another. Even during the collision, most stars will never touch. Instead, they will shift, merge into new patterns, or be flung into deep space. Earth, the Sun, and our solar system will be carried with the Milky Way as it falls toward Andromeda. Our skies will change. The calm darkness of space will become a stage for one of the greatest shows in the universe. The collision between the Milky Way and Andromeda is not chaos without order. It follows the rules of physics, gravity, and time. It is a story written in the motion of stars, long before humans existed to witness it. Imagine standing on Earth 4 billion years from now. The sun is older and brighter. The oceans may be shrinking as temperatures slowly rise. But above all of this, the night sky has changed forever. The Andromeda Galaxy, once a faint blur, now stretches across the sky. It grows larger every 1,000 years, forming a glowing arc of stars, gas, and dust. Eventually, it becomes bigger than the moon, brighter than anything we have ever seen besides the sun. This is the first stage of the collision. The Milky Way and Andromeda will begin to overlap. Their edges will touch first. Stars will be pulled from their spiral arms. Long streams of stars will stretch like ribbons across space. Astronomers call these tidal tails. They are made of stars, gas clouds, and even newborn star clusters, all dragged by gravity. Will Earth be destroyed? Most likely no. The chance of a star physically crashing into our sun or Earth is extremely small. Even though both galaxies contain hundreds of billions of stars, the distance between individual stars is vast, trillions of kilometers. Space is mostly empty. But the gravity of nearby stars could disturb the solar system. Our sun might drift to a new place in the galaxy. The orbits of planets could shift slightly. Far objects like comets in the Oort cloud could be pulled into the inner solar system, causing more impacts on planets and moons. Still, Earth itself will not collide with another planet. Instead, the danger comes from the aging of our sun. By the time the collision begins, the sun will be almost twice as bright as it is today. The oceans may have evaporated. Earth could be too hot to support life. If humans survive to see this era, they may have already left Earth, living on Mars, moons, or artificial worlds across the solar system. As the two galaxies pass through each other for the first time, they will not immediately merge. Instead, they will separate again, pulled apart by gravity. But they will remain connected, like partners in a slow cosmic dance. They will swing around each other and collide again and again. With every pass, stars will be rearranged. Gas clouds will crash, creating new stars. The sky from any inhabited world will be a glowing swirl of light, chaos, and beauty. The calm spiral shape of the Milky Way will disappear. In its place will be twisting bridges of stars connecting two galaxies locked in a gravitational embrace. And this is only the beginning. After the first encounter, the Milky Way and Andromeda will not instantly merge into one. Instead, they will drift apart, slow down, and then fall back toward each other again. This dance of gravity will take hundreds of millions of years. Each time they pass, the galaxies will lose more of their original shape. Their spiral arms will stretch, twist, and eventually tear apart. They will not look like elegant spirals anymore. They will look like two glowing clouds of stars merging into one. This is the beginning of a transformation. Gas and dust within both galaxies will collide and compress. New stars will burst into existence. Some will be massive, bright, and short-lived. Others will be smaller, like our sun, and may live for billions of years. These new star-forming regions will light up like cosmic fireworks. But this burst of life will not last forever. As stars form rapidly, they will burn most of the available gas. Eventually, star formation will slow down, and a calmer galaxy will begin to emerge. Scientists believe the result will be an elliptical galaxy, rounder, smoother, and brighter at the center. Astronomers have even given it a name, Milkdromeda or Milkomeda, a combination of Milky Way and Andromeda. What about our sun? By this time, the sun will be near the end of its life. It will run out of hydrogen and begin to swell into a red giant. It may expand wide enough to swallow Mercury, Venus, and possibly Earth. Even if Earth survives physically, its surface will be scorched and lifeless. However, the solar system might not even be in the same part of the galaxy anymore. As the galaxies merge, gravity could fling the sun into a new orbit, far from where it began. It might end up near the outer edge of the new galaxy, or even be pushed into intergalactic space, a star drifting alone in the dark. And what about the hearts of both galaxies? At the center of the Milky Way lies a supermassive black hole called Sagittarius A star. Andromeda also has a supermassive black hole even larger. As the galaxies merge, these two giants will slowly move toward each other. They will orbit one another, drawing closer over millions of years. Eventually, they will collide and merge into one even larger black hole. That final collision will release more energy than all the stars in the galaxy combined, in the form of gravitational waves, ripples in space and time. After the chaos settles, a new galaxy will stand, quiet, massive, and filled with old stars, glowing softly in the darkness. As the Milky Way and Andromeda begin their long collision, a natural question rises. What will happen to Earth? What will happen to humanity? If human civilization still exists by then, it will be at least 4 billion years older than it is today. Earth will already be growing warmer because the sun will be shining more intensely as it ages. Oceans may begin to evaporate, and life on the surface may struggle to survive. By the time the galaxies collide, humanity will face two possibilities. First, we remain on Earth. If that happens, survival will become increasingly difficult. Rising temperatures, changing atmosphere, and eventually the sun's red giant phase will make Earth uninhabitable. The planet may be swallowed by the expanding sun or scorched beyond recovery. Second, humanity leaves Earth. If we become a spacefaring civilization, we may colonize Mars, moons like Titan or Europa, or planets orbiting other stars. Advanced technology may allow humans to travel to planets like Proxima b around Proxima Centauri, or even build giant space habitats. But during the galaxy collision, does Earth face immediate danger? Surprisingly, the answer is no. Even though Andromeda holds about 1 trillion stars, the distances between stars are so great that direct star-to-star collisions are extremely unlikely. If you compress the Sun and the nearest star, Alpha Centauri, down to the size of grains of sand, they would still be several kilometers apart. So when galaxies collide, it is mostly empty space passing through empty space. Earth will not crash into another planet, The sky will change, but the ground beneath our feet will remain stable, at least at first. But the sun's orbit will change. Earth could be thrown into a different part of the galaxy. We might drift into a quieter region, far from the galactic center. Or we could be pulled closer to areas rich in radiation and cosmic chaos. There is even a chance the sun could be flung out into the cold void between galaxies, turning our world into a drifting planet without a sun. If humanity survives this far into the future, our survival will depend on technology. Generations of humans may live on colossal starships, artificial worlds, or planets around distant stars. We may witness the collision not from Earth, but from a safe distance, looking back at two glowing galaxies twisting together like ribbons of light across the sky. It would be one of the greatest sights in cosmic history. And if humanity has vanished by then, the collision will still happen. Galaxies will still dance. Stars will still be born and die. The universe will move on, with or without us, because the story of the universe is bigger than Earth, bigger than the Milky Way. It is a story written in gravity, light, and time. As the Milky Way and Andromeda begin their long collision, a natural question rises. What will happen to Earth? What will happen to humanity? If human civilization still exists by then, it will be at least 4 billion years older than it is today. Earth will already be growing warmer, because the sun will be shining more intensely as it ages. Oceans may begin to evaporate, and life on the surface may struggle to survive. By the time the galaxies collide, humanity will face two possibilities. First, we remain on Earth. If that happens, survival will become increasingly difficult. Rising temperatures, changing atmosphere, and eventually the sun's red giant phase will make Earth uninhabitable. The planet may be swallowed by the expanding sun or scorched beyond recovery. Second, humanity leaves Earth. If we become a spacefaring civilization, we may colonize Mars, moons like Titan or Europa, or planets orbiting other stars. Advanced technology may allow humans to travel to planets like Proxima b around Proxima Centauri, or even build giant space habitats. But during the galaxy collision, does Earth face immediate danger? Surprisingly, the answer is no. Even though Andromeda holds about 1 trillion stars, the distances between stars are so great that direct star-to-star collisions are extremely unlikely. If you compressed the sun and the nearest star, Alpha Centauri, down to the size of grains of sand, they would still be several kilometers apart. So when galaxies collide, it is mostly empty space passing through empty space. Earth will not crash into another planet. The sky will change, but the ground beneath our feet will remain stable, at least at first. But the sun's orbit will change. Earth could be thrown into a different part of the galaxy. We might drift into a quieter region, far from the galactic center. Or we could be pulled closer to areas rich in radiation and cosmic chaos. There is even a chance the sun could be flung out into the cold void between galaxies, turning our world into a drifting planet without a sun. If humanity survives this far into the future, our survival will depend on technology. Generations of humans may live on colossal starships, artificial worlds, or planets around distant stars. We may witness the collision not from Earth, but from a safe distance, looking back at two glowing galaxies twisting together like ribbons of light across the sky. It would be one of the greatest sights in cosmic history, and if humanity has vanished by then, the collision will still happen. Galaxies will still dance. Stars will still be born and die. The universe will move on, with or without us, because the story of the universe is bigger than Earth, bigger than the Milky Way. It is a story written in gravity, light, and time. The collision between the Milky Way and Andromeda is not a disaster. It is part of the universe's natural rhythm. Stars are born. Stars die. Galaxies grow. Galaxies fade. The universe changes, but it never stops creating something new. Long after the merger, the new galaxy will drift through space in silence. The stars will age. Their fuel will burn out. The night skies of any surviving world will shine with ancient, dying light. But somewhere, perhaps around a distant star, a civilization may look up and wonder. They may not know the Milky Way or Andromeda by name. They may live in Milky, unaware of the two galaxies that came before. Yet they will still ask the same questions we ask today. Where did we come from? What is our place in the universe? How far can we go? The story of galaxies is also the story of us. We are made of the ashes of ancient stars. Our atoms were forged in supernova explosions billions of years ago. We are not separate from the universe. We are the universe, looking back at itself and trying to understand. The collision between the Milky Way and Andromeda is far in the future. It will not happen in our lifetime. But thinking about it changes how we see everything. It reminds us of how small we are, and how extraordinary it is that we are here at all. In this brief moment of cosmic time, we can explore, discover, and understand. And that is our greatest gift. If you enjoyed this journey into the future of our galaxy, stay with us. There are many more stories hidden in the stars, waiting to be discovered. Subscribe to join this ongoing exploration of the universe. Thank you for watching. Until next time, keep looking up.